All right, for this problem, we are asked to calculate the magnitude of the tension T and the angle theta for which the eye bolt will be under a resultant downward force of 15 kilonewtons. So, we don't have a coordinate system here, but we could certainly apply one very quickly. We could just call positive x to the right and positive y down. And with those axes in place, we're essentially trying to determine what this magnitude and angle are so that the resultant of these three forces is purely in the y direction and is directed downward with a magnitude of 15 kilonewton. So what that tells us is the x component of r, which is the sum of all the forces in the x, would have to be equal to 0. And that tells us that the y component of r would have to be equal to 15 kilonewton, and that's the sum of the forces in the y. So these are the two equations that we must solve, and we have two unknowns, t and theta, but we might solve this in kind of a different way, so we don't solve directly for t and theta, but I'll show you a couple different ways. All right, so let's start with the normal version. Let's solve Rx equal to 0, and that would be the 6 kilonewton is purely in the x direction. I have an 8 times the sine of 30 degrees for this load here. And then the t has a minus t times the cosine of theta component, and that would be equal to 0. So I could solve this for t times the cosine of theta, and that would be 6 plus 8 times the sine of 30 degrees. And if you need to, you can certainly sketch your vector components here. I'm going to go ahead and sketch a few. Let me go with orange, and especially for the tension T. So T has a leftward component and a downward component. This is Tx, and that's T times the cosine of theta. And then this is Ty, and that is t times the sine of theta. Okay, and then the 8 kilonewton is going to be the sine of 30 for this right-hand side, and the cosine of 30 for the y. But here's one equation, so we can solve this equation, but we have a problem that because it says t times the cosine of theta is equal to 6 plus 8 sine 30. So there's two unknowns in there. So we won't despair. Let's write the ry expression and see what happens. So we know that ry is equal to 15 kilonewtons. And down is positive, so I have a positive t sine theta. And then I have a positive 8 cosine 30 degrees. And I could solve this for t sine theta, and we would get that t times the sine of theta is equal to 15 minus 8 times the cosine of 30 degrees. So here's my second equation. And what I could do is take equation 2 and divide it by equation 1 so that I have t sine theta over t cosine theta, and that would be equal to 15 minus 8 cosine 30 degrees divided by 6 plus 8 sine 30 degrees. And on the left-hand side, we can see that the tension will cancel out, and sine theta over cosine theta is the tangent of theta. And I'm left with a mess of numbers. All of these are known quantities. So if we take the tan inverse of it, we would get theta, and it turns out that theta is 38.9 degrees. So now we know theta. And knowing theta, we could plug back into either expression that we previously had. We could insert here, or we could plug in here, and we could compute the tension T. And we would find that T is equal to 12.85 kilonewtons. So there's T and theta. Now, alternatively, what we could have written was the components of t in the equations instead of the product of t and the angle. So, for instance, in Rx, we could have said, well, t cosine theta is really tx. So we could have said that this is tx. And we could have computed a number for tx. Tx for this number would come out to be 10 kilonewtons. And then here, where I have my t sine theta, I could have plugged in ty for that. So this would be equal to ty. And ty is equal, in this case, to 8.07 kilonewtons. So, at this point, I would be able to see that theta is the tan inverse of ty by tx. So that's the tan inverse of 8.07 divided by 10. And that number comes out to be 38.9 degrees. And I could have said that t is the square root of tx squared plus ty squared. And that would be equal to the square root of 10 squared plus 8.07 squared. And that number is 12.85 kilonewtons. It's essentially the same thing. It's just whenever you're trying to solve for an unknown angle, you can sometimes run into calculation problems that when you have unknowns that multiply each other, it becomes a little harder to solve for. This one isn't a bad example. This one's pretty straightforward. But this is a little trick you can do, where instead of solving for an unknown tension and an unknown angle, you can say, well, that is a component, and solve for the component and get an actual number, and then use the components to determine the other pieces of the vector. We find vector components, and then we get a vector magnitude and a vector direction. So that's all we have to do for this problem.